forensics time on Science in the City, and we're here at the Trent University Forensics Department Crime Scene House. I'm joined by some of the top students in the forensics department, and Glennis Price, who is the forensics department lab technician, and we are going to answer one of the great mysteries of forensics. How do you go from a DNA swab on the wall at a crime scene to those funny pictures we see with all those bands? And we're going to do some electrophoresis. Okay, so Glennis, what is electrophoresis?
Well, basically, it's the application of an electrical current to something, and it moves fragments based on that current.
Okay, so fragments or molecules of a substance will move at different rates through the electrical current based on their size. And if you want to understand electrophoresis, well, we're going to use one of my favorite chemicals, food coloring, to try to understand what electrophoresis does at a molecular level and how that eventually will apply to DNA. Okay, so for the first test, we've got an electrophoresis chamber here, and we're going to load up different food colors. This is a brown glop brown glop that's made up of several different colors of food coloring. Okay, let's load this thing up. In the gel, there's a whole bunch of little wells, and the sample goes into each well. When we apply the current, the food coloring molecules are going to move through that gel. They'll move at a rate determined by their size. So small molecules move faster than big molecules.
Right.
And we'll see some banding, some spreading out. Kind of cool. Okay, let's fire this thing up. Okay, you guys ready for the big reveal here?
Yeah.
The food coloring electrophoresis. So this has been cooking for a while. Ready to see what it looks like now?
Yes.
Okay, let's open it up and see what we've got.
Oh, wow.
Ooh, it's kind of a pretty picture there.
Yes.
And every picture tells a story.
True.
And so remember, in the electrophoresis, different molecules move through the electric field at different rates. And that's why we get the separation. Look at that over there. Blue and yellow on that side. And what did it start out as?
Green.
It started as green. So going back to grade 1. Blue and yellow makes green, right? Okay. So we were able to use electrophoresis to separate out the different colors. We got some great banding there with the food coloring, right?
Yeah.
Right.
The bands that we saw are kind of like the bands that we see in those DNA profiles. So now it's time to put some DNA into the electrophoresis chamber and see what we get.
All right.
Now, we've got some DNA samples here, but we don't use the whole DNA molecule, do we?
No, it's way too large to be running on this gel.
Okay.
So we brought you some samples that have just smaller fragments of that in it.
So let's load it up and let's see what we get when we run DNA through an electrophoresis field. Okay, let's put the lid on this thing and fire it up. Okay, snap that on. Now this is just like the food color setup, and so the molecules of DNA, the fragments of DNA, are going to start to move through that current. So we'll see some banding or some separation based on the size of the fragments. Okay, so we've got our second electrophoresis sample here. It's been cooking away. Now, I did food coloring. You guys kicked it up a notch, so the DNA. Let's see what we end up with here. Okay, that's kind of cool. What do we see?
So just like when we put the food coloring in, we put a dye in with our DNA so it makes sure that it stays down in the well so we don't lose all our DNA when the current runs through.
Okay.
And so this just shows us that our sample has indeed moved through the gel.
The dyes are not the DNA.
No,
The DNA is invisible.
it is, and with this UV light box, we'll make it visible.
Okay. Oh, now that's very, very cool. We're seeing bands there, kind of like the colored bands that we saw with the food coloring, but with a little more detail. Adrian, what are we seeing with those bars?
We're seeing different sized fragments of DNA. The smaller ones move further down the gel than the bigger ones.
Now, what makes my DNA fragments different than your DNA fragments?
Just different fragment sizes.
So my DNA is different than, we all have different DNA, right? Most of it's the same.
Yeah.
But there's little bits and pieces that are different. And if you pull out those little fragments, put them in the electric field, your fragments move at a different rate than my fragments. Okay, let's try to figure out what we've learned here. We've got this process called electrophoresis, right?
Yeah.
Molecules of different sizes move at different rates in this electric field. And we saw it with the food coloring. And then we saw it again with the DNA. So it's a little bit of physics and a little bit of chemistry.
And a whole lot of forensics.